Welcome to Sairam Educational Channel. Today in this video we will learn about nitrogen oxides and their structures. So nitrogen forms different oxides from plus 1 to plus 5 oxidation states. It can have plus 1 or plus 5 oxidation state and forms different types of oxides. The oxides, different oxides are, we will write here oxides, NO, nitric oxide, N2O, nitrous oxide, NO2, nitrogen dioxide, NO, N2O, NO2. So nitric oxide, nitric oxide, nitrous oxide, nitrogen dioxide, The next will be N2O3, dinitrogen trioxide, N2O4, dinitrogen tetroxide, N2O5, dinitrogen pentoxide, You see, these are the different nitrogen oxides, starting with NO, nitric oxide, nitrous oxide, nitrogen dioxide. This we can call also nitrogen trioxide simply, but it is dinitrogen trioxide. Nitrogen tetroxide it is. This is dinitrogen tetroxide. This is dinitrogen pentoxide. These are the 6 types of nitrogen oxides. Today we will see about these oxides, chemical structures, how to write their formulas and chemical structures, and if possible the structures. Okay, let us start with the one by one. So whenever you want to write these structures easily, better you remember first what are the total number of valence electrons in each one. For example, we will try to write first N2O, nitrous oxide, N2O. How to write the structure? You see, first you calculate the number of valence electrons available in this compound. You see, nitrogen, right here, atomic number is 7, and it has configuration 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. Total 7. Oxygen, atomic number 8. So 1s2, 2s2, 2p4. You take this K shell out. The next one is called L shell, that is the valence shell. Clear? So in this valence shell, nitrogen is having 5 electrons, oxygen is having 6 electrons. Now those are the valence electrons. Now you calculate for this particular one, how many nitrogens are there? 2. So 2 5 is 10. 10 plus oxygen is 6. So total I have 16 electrons. 16 valence electrons. So you try to use these 16 valence electrons and adjust the bondings. Easy to understand. First, you take the N2O. So N and O. Clear? N2O. So you put the bonds, whatever generally we do. So total I have 16 electrons. So 8 pairs of electrons are there. So I will give 2 pairs over here, 2 pairs over here. Or you can give one, then you give other one. Anything is okay. So 2 to 4 pairs are over. Still I have 4 more pairs. Generally oxygen will have 2 bonds and lone pairs. You give 2 lone pairs. It will have 2 lone pairs. So we have given 2 lone pairs for the oxygen. Total how many for next? Similarly, nitrogen can have 1 lone pair. That's what general. So now you can count the number of electron pairs. 1, 2, 3, 4, 5, 6, 7 pairs. So we left with one more pair of electrons. Correct? So this one pair, another pair can be given to the nitrogen. So now if you can see here you have total 8 pairs of electrons, 16, 1, 2, 3, 4, 5, 6, 7, 8 pairs of electrons. So this is the way we can easily write this particular structure. This is one form. Its resonance form also can we try to write. You can write next to it resonance form. So if you think that here we are not writing charge, otherwise you generally should write the charges like plus and negative, because nitrogen got more than its valence electron, so it gets negative charge. This lost its lone pair electron to this bonding towards, because it should have 3 bonds and 1 lone pair. That bonded pair went here, that means 1 electron it lost, so it will get plus. But in these structures I am not writing the charges, simply we will only put the number of electrons. These structures can be acceptable like this. So still if you want to write for a resonance, you should have to put the charges. Charges wherever you have more number of electrons, put negative charge. Where you have lost the electrons, put positive charge. So here positive, here negative, we will get it. This oxygen will not get anything because it has 2 bonds and 2 pairs of electrons. Clear? So such a way we can. Now if you want to write the resonance from this, you can give NN triple bond. That means this bonded pair will go here. If whenever it goes, this bonded pair should go to the oxygen. That is the another form. So N and O. So what will happen now? I will be giving triple bond here. That means 1 lone pair only will be left. 1 lone pair went here. The nitrogen is same. This paired electron goes here. So I have a single bond here. Then 3 lone pairs. 1, 2, 3 lone pairs. Now also you can count the number of electrons. Total oxygen is having 4 pairs. 1, 2, 3 lone pairs and 1 bond pair. 4 pairs plus 3, 7 pairs plus 1, 8 pairs. So this is the way we can able to adjust its molecular structure. So as you see in this structure, you can say that it is a linear one, linear shape. It is a linear one. So the bond parameters also we can able to try. So linear and bond parameters, the lengths, NN bond length is around 113 picometer. NN bond length is 113 picometer. And the NO bond length is around 119 picometer. So this is the nitrous oxide. We generally call also laughing gas, correct? So nitrous oxide, the molecular structure can be written like this, and the bond parameters, if you can see, NN bond length is 113 picometer around, NO bond length is 119 picometer. Okay, I hope you understood. So similarly we can write all other structures. So we will write the next one, N2O over next NO, nitric oxide. You have only nitrogen and oxygen. You know that nitrogen and oxygen. So I can put N and O. How many electrons will be there? It is 5, it is 6, correct? Total 11 electrons. 11 electrons. So 5 pairs and 1 electron extra. So you put the pairs, first you can give a double bond here and 1 lone pair here, 1 lone pair here, 1 lone pair. This is generally what we know. So 1, 2, 3, 4, 5. 5 pairs over 10 electrons, 1 electron left. 1 electron you can give it to N or O based on the resonance structures. You can give for N one time, other time you can give it to oxygen. So N double bond O. So 1 lone pair already there, 2 lone pairs already there. So this 1 electron can be given here. That's all. So this is the simplest way we can write the bonding in the nitric oxide, NO bonding will be like this. You can write 2 resonance forms, and NO bond length here it is around 115 picometer. 115 picometer. It is also a linear molecule. So NO, nitric oxide, see here we have seen the calculate total number of valence electrons, that is valence electrons. Nitrogen is having 5, oxygen is having 6. So 5 plus 6, 11 total electrons. I have 10 pairs and 1 electron extra. So try to write like this, NO. You give, as we know generally, 2 lone pairs on oxygen, 1 lone pair on nitrogen, and 2 bonds in between. Total I can have 5. Oxygen perfectly have its octet. So nitrogen, 1 extra electron is there, you give to nitrogen one time. Next time you give to oxygen. So this gets negative, this gets negative based on the structures. Clear? So this is the linear molecule and total bond length is around 115 picometers. Clear? So next we will go to the other compound. NO is done. So now we will see the NO2. NO2. Nitrogen dioxide. So nitrogen is once again 5 electrons and oxygen is 6, 12. So 5 plus 12, total is 17 electrons I have. So nearly 8 bond pairs we are having, and the remaining is 1 lone pair of electron, 1 electron extra. So you can write nitrogen dioxide N. So it is a triangular shape, so you can write like this, NO and NO. So you can have 1 lone pair here, 2 lone pairs here generally. So this is the way we can write total. How many it becomes now? 6 lone pairs are finished. 3 bond pairs and 3 lone pairs. But here also we will have 2 lone pairs. Clear? Oxygen. 1, 2, 3, 4, 5, 6, 7, 8 lone pairs is over 16 over 1 electron is extra. 1 electron we have extra. So this 1 electron you can put it where you want. So this is the way we can able to try to write, but the electron, 1 electron we have to try. So what we will do, this lone pair can be given here and that electron can be written here. 1 electron. So such that it will get negative charge. Clear? That lost 1 electron, so it will get positive charge. So now this way also we can able to write. Now you can count 1, 2, because it doesn't have 1 bond. That's why I have given a lone pair here. Here it is having 2 bonds, so you can't give more than 2 lone pairs. So here I have 3 lone pairs and 1 bond pair, 4, and then 5, 6, 7, 8. 8 pairs, 16 plus 1 electron, 17. So this is one way we can able to write. This is the one resonance form. Another resonance form is, in between these 2 oxygens you exchange the bonds. Here I have double bond, here you can make it single bond, here you make the double bond. So such a way we can write the another resonance structure. So I will put here double bond O. Double bond O, the same one with 2 lone pairs of electrons. Clear? And this single bond is here. Okay, this should be that side. Oxygen. So there is a exchange, delocalization of electrons between these 2 oxygen molecules, atoms. So such that it gets a resonance form. So oxygen will have once again 3 lone pairs. That means it is negative charge, it is positive charge. Charges we are not writing, as I told initially. So only the electrons we are concentrating. So you can see the total number of electrons are registered, 17 electrons. In this NO2 molecule, as we seen, it is a angular in structure. Okay, angular in shape. Angular. So it is angular in shape. And also the bond length, NO bond length is 120 picometers. NO bond length is a hybrid of these 2. One is double bond, single bond. Hybrid of these 2 will come. So that bond length is 120 picometers. NO bond length is around 120 picometers, and the angle, it is angular. This angle will be 134 degrees. 134 degrees. So such a way we can try to write the NO2 structure. NO2 structure. So this is the nitrogen dioxide. So we will see other 3 more one. I hope you are understanding, following. If you are not, you can just go through once again. If you have any queries or doubts, please post in the comments box below, such that we can revert back to you. Okay. The next one is N2O3. N2O3. As we told, total number of valence electron, nitrogen is 5, 5, 10. This is, and this is 6, 6, 3, 18, total equal to 28 electrons we have. We have around now 28 electrons. So N2O3, if you are writing, you can write N and N, double bond O and single bond O, or double bond O. Like this. This is the simplest way we can able to try. Wherever it possible, similar normal structure was given. Okay, since I have, if I don't have this oxygen, I can write like that, simplest way. Since we have one more oxygen, we have written like this. So now you see the bond pairs, how many, next to lone pairs you can give whatever known lone pairs. Since it is having single bond, you can give one more lone pair also, but you can count the total number of electrons, then we will see. So 3 lone pairs and 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 26 electrons are over. So 13 lone pairs are there. So you have finished now around 23 electrons. So one more lone pair was left over with. So where we can give, because nitrogen should, here you would have given another lone pair, because already nitrogen 3 bonds and 1 lone pair, it is obvious. So we can give this lone pair over here. So now if you can count, the total number of lone pairs are same, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14 lone pairs. Total you have 28 electrons. Such a way we can able to write N2O3, nitrogen trioxide, that is dinitrogen trioxide. So the resonance form, if you can write the resonance form like this, you can put and write. I will be writing here. So if I write the resonance form N, and here you can change these bonds towards this to be here. So N double bond O and single bond O, and this N double bond O will be here. That's all. So you put the number of electrons same, 1, 2, 3, 4. Next here we will not get anything because it gets positive charge, because it has given the electrons here. So like this. This is the another resonance form of the same. Just this oxygen moved towards this nitrogen. Okay, remaining is same. So this is the way we can able to write the second resonance form of N2O3, and you can now find out the NO bond length is around 114 picometer. This NO bond length is 114 picometer. 114 picometer. NO bond length is around 114 picometer. Another NO bond length is 120 picometers. For example, if you can see, you have two NOs. One is double bond, one is single bond. Correct. So this single bond will be higher, so 120 picometers bond length. So this is the double bond. NO bond length is 114 picometer. NO single bond length is 121 picometer. NON, this angle will be 130 around picometer, 130 degrees. Sorry, 130 degrees. So like this we can have different bond parameters, which you also sometimes useful to compare the molecules or better to understand it. So and the shape, as you saw, it is a planar shape. Oh, it is in a plane. So planar shape. So this is the way we can able to understand N2O3. I hope you understood. Total 28 electrons. I have given simplest way NN, 1 O, 2 O's, and bonds whatever we know we have given. N is having 3 bonds lone pair, oxygen 2 bonds lone pairs, oxygen 2 bonds lone pair, oxygen single bond, so 3 lone pairs. Since N is having lowest its bond pair, you remove the bond pair here because it is having 4 already bonds. Okay, so such a way we can able to understand N2O3. Similarly, we will try to write N2O4. So N2O4 is here, it is 10 electrons and 24 electrons, total 34 electrons we are having. 17 pairs of electrons we are having. So N2O4, if you can write N, anyhow each one will have 2 oxygens. Clear? So I can put 2 oxygens here like this. So one double bond, remaining 2 bond. So double bond wherever you have, you put a lone pairs. Here also you put a lone pairs. And here you can put 3 lone pairs. 3 lone pairs. Now you can count the total number of lone pairs. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So 17 to 34. So total we have given 34 number of electrons, and this is the way we can able to write the N2O4 structure. N2O4 structure. So what is the resonance form we write? Whichever the oxygen having single bond, you make it to double bond. The single bond, double bonded oxygen can have single bond. So such a way we can able to write this particular one. So you can see N single bond O here. Here it is double bond O. Then N, there it is double bond O. Here it is single bond O. So electrons are same, 1, 2, 3, 4, 5, 3 pairs here. Here also you can have 3 pairs. Here we can have 2 pairs. So such a way we can able to write the resonance structure of this particular N2O4. N2O4 we have written the resonance structures, and it is also planar molecule. The bond length here it is around 175 picometer. 175 picometer, that is NN bond length. So NO bond lengths already we have seen, that is double bond length is very less. But both the case the bond length will be common because they are in resonance form. So the bond length is around 121 picometer. 121 picometers. Okay. So the angle is here 135 degrees. All these things we know. So the last one we will try to see N2O5. N2O5. So N2O4 we have seen, and now we will see the last one N2O5. So this is 30 plus 10, 40 will be the total. So okay, see. So the next we will see N2O5, dinitrogen pentoxide. So you see the nitrogen is having 5 electrons each, so total 10 electrons, and oxygen is 6, we told 6 5 is 30 electrons. Total you have to adjust 40 electrons. How many electrons we are having? 40 electrons. So this 40 electrons, how we can say, similar to the previous one we can able to try. Just we have one oxygen extra, so you put this oxygen in between, and remaining will be same like this. You can have single bond and double bond. So all these N2O5 we have written. Now you can give the known lone pairs. Here 3 lone pairs, correct? Here 2 lone pairs. Oxygen is having 2 bonds, so 2 lone pairs. Here oxygen is having 2 bonds, so 2 lone pairs. Here it is having 1 bond, so you can give 3 lone pairs. Now you count the total number of electrons. 1, 2, 3, 4 pairs. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So 20 pairs, it is around 40 electrons, correct? So such a way we can able to simply write this N2O5 structure, and it is planar in nature, and this bond is around 112 degrees, and the bond length NO is 115 picometers, and NO external bond is around 119 picometers. This bond both will be same because resonance form. When you write this to be here, this to be here, so the bond length will be equal, so 119 picometers. And it is a planar in shape. So such a way we can able to understand all these nitrogen oxides structures and their bond parameters. N2O and NO are both are neutral oxides. So N2O and NO, both these oxides, N2O and NO, both are neutral oxides. Remaining all oxides are acidic in nature. Okay, thank you. We will see in the next video some more concepts from this +2 chemistry. Thank you.